Hi, this is Jim from AWS. The topic of this session is migration and tools. The design and migration phases form an iterative process for migrating waves of applications. From the previous design phase, we determined the migration approaches with respect to rehosting, replatform, and refactoring. We also designed our application architecture based on the AWS well-architected framework. Now we are to perform migration according to the prioritized backlog of applications. The migration phase actually consists of 3 steps: migration, integration, and validation, as illustrated in this diagram. Let's go through these steps. First, workload migration. There are different types of workloads for migration. For example, server, VM, or container workloads, database, and the data alone for archiving. In this session, we focus on the server workload migration, which is commonly required by rehosting and replatform approaches, and also indirectly by refactoring as well. In the migration process, our first step is to understand and nail down the customer's requirements, and accordingly determine migration methods and tools. From the technical perspective, here are some of requirement considerations we need to go through with our customer. For example, what's customer's expectation on migration duration? What's the requirements time objective, which is related to cutover time? And how about the recovery point objective? It's about tolerance to state and the data loss a customer can consider. And what's the requirements for multi-volume support, securing data in migration, and subnetting and the VLAN changes? Those are the customer requirements we need to consider and need to take into account. A number of methods can address the migration requirements just described above. Here we highlight a few methods in the terms of ways to capture server or VM content and approaches to minimizing downtime at cutover. VM conversion is a migration method that transports VM images on-premise to the cloud and convert them to the image format used in the cloud. For example, a VMware VMDK image is imported into AWS, then converted to AMI image. The AMI image is then used to create EC2 instance. VM migration can be performed through either block-level VM capturing or file-level VM capturing. These are typical mechanisms used by different migration tools. Incremental replication is a way to synchronize the content of VMs in the source and the target environments. Its purpose is to minimize the RTO, that is, recovery time objective, at the time of production cutover. Now let's look at some of the tools that implement these methods. AWS and AWS partners provide tools for server migration. One of the tools is called import-export, which move VM images to AWS and then convert images to AWS machine images. We are to illustrate the import-export process on the next slide. Another AWS tool is Server Migration Service, which captures and moves the image of VM in running state, and it can further replicate the state of the running VM on-premise to the migrated VM running in the cloud. We demonstrate this Server Migration Service process in a subsequent video session. In addition to the AWS server migration tools, several AWS partners offer migration tools as listed here. We are to show an example of block-level VM capturing employed by the Cloud Endure tool. There are also service partners who can perform workload migration for customers. You can find migration service partners at this AWS website. Now let's take a look at the AWS image import-export process. As we can see from this diagram, in the data center on-premise, a VM is first exported from the virtualization environment to an image in the format of raw, VHD, or VMDK. The image is then imported to AWS S3. Next, the migrated image is either converted to an AMI image or turned to an EC2 instance. The AMI image can be further copied to other regions. Block-level VM capturing and replication is another server migration method. For example, let's take a look at the block-level replication process performed by partner Cloud@Endure. Here are two environments, source data center and the target cloud. In the source data center, Cloud@Endure agent is installed on source virtual machines or physical servers that run applications on Windows or Linux or other platforms. The agent continuously replicates data into a staging area in the AWS cloud. In the staging area, the EC2-based replication server stores the data in the elastic block storage. At the time of migration cutover, Cloud@Endure takes the data volumes in the staging storage to the EBS on the target location. It then performs conversion of boot volumes by injecting Amazon Zen hypervisor driver, making bootloader changes, installing cloud tools, etc. It brings up target instances in a few minutes. From this example, we can see how the source machines are replicated at block level to the AWS target environment, and then cut over to production in the cloud. This table summarizes server migration methods and tools we just went through. For details, the audience can refer to AWS documentation and vendor tool materials with the URLs provided earlier. After we have done the migration, we then go into validation and integration tasks. The validation is all about functional tests and performance tests. The integration is to tie the application components end-to-end and with the underlying cloud infrastructure. The validation and integration can be an iterative process. Another step of the validation process is a business sign-off. This could be the business owner or a change management process that gives the green lights to cutover. Cutover refers to a process that changes production on-premise or staging in cloud to the new production in the cloud. There are a few factors to consider prior to the cutover. We discussed the recovery time objective and the recovery point objective earlier. It is a must to have a rollback plan to ensure production continuity in case of cutover failure. In summary, for migration, we need to first identify customers' requirements, understand the different migration methods. Accordingly, we select migration tools. Using the tools, we perform migration and then do migration, integration, and validation. With a backup plan in place, we can switch from the source environment on-premise to the target environment in the cloud. Thanks for watching.